One of the first things you've probably learned in calculus, or at least when learning about derivatives, is that the derivative of sine of x is equal to cosine of x. This is a standard derivative, and we sort of just accepted that as a fact without thinking too hard about why. So what I want to do today is unpack how we even know this is true, and prove that the derivative of sine of x is indeed cosine of x. Recall that the limit definition of the derivative for a function f of x is d by dx of f of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. If we apply the limit definition of the derivative for the function sine of x, then d by dx of sine of x is equal to the limit as h approaches 0 of sine of x plus h minus sine of x, all over h. The next thing to do is to expand the expression sine of x plus h using the compound angle identity sine of a plus b equals sine a cosine b plus cosine a sine b. If we use this identity on sine of x plus h, we end up with sine x cosine h plus cosine x sine h, and the minus sine of x stays the same, and all of this is divided by h. We can also split the fraction and rewrite this as the limit as h approaches 0 of sine x cosine h minus sine of x all over h plus cosine x sine of h over h. And what I've done is I've grouped sine x cosine h and negative sine of x into the first fraction, and the cosine x sine h term goes into the second fraction. If we factor out sine of x from the first term, it becomes cosine h minus 1 over h times sine of x. And if we factor out cosine x from the second term, it becomes sine of h over h times cosine of x. We can use the limit law for sums to rewrite the single limit as the limit as h approaches 0 of cosine h minus 1 over h times sine of x plus the limit as h approaches 0 of sine of h over h times cosine of x. Because each of the individual limits in the sum exist. We know that they both exist because sine of x and cosine of x can be treated as constants since the limits are in respect to h, and sine of x and cosine of x are in terms of x, and the limits of cosine h minus 1 over h and sine of h over h as h approaches 0 both exist as well. The limit as h approaches 0 of sine of h over h is equal to 1, which has a geometric proof, which I already did a video on, and the limit as h approaches 0 of cosine h minus 1 over h is equal to 0, which I also did a video on. I'll link both videos in the description. So if we plug in these values, the limit as h approaches 0 of cosine h minus 1 all over h times sine of x is equal to 0 times sine of x, and the limit as h approaches 0 of sine of h over h times cosine of x is equal to 1 times cosine of x. The expression becomes 0 times sine of x plus 1 times cosine of x, and the first term disappears because of the 0 term, and simplifies to cosine of x. We started with the limit definition of the derivative of sine of x and ended up with cosine of x. So the derivative of sine of x is cosine of x.